Hi, this is Ms. Schultz. So this is finally part 4 of this Diff Equs classwork. I'll be showing you all the work, but I'll just be asking like an intermediate question and then the final answer per each question. So I'll be moving a little quicker. So this is part 4, numbers 9 through 12. Okie dokie, let us get started. Okay. So we have this differential equation. So can you please do the following steps? So can you please, so for e to the y problems, it's a throwback to I wouldn't start solving for y before you plug in to find the c. So I would just integrate both sides, integrate, and then I would just sub in right from there. Sub in to find plus c. And of course you're subbing in your initial position. So, and then you're finding the c, not like e to the c or anything. All right, so why don't you go ahead and do that. Alrighty, and let's join back up. Okie dokie. So, all right, that's the separation of variables. Okay, that's the, I just rewrote it, so you need to rewrite in order to integrate, okay? So when e is in the, when an exponential is in the denominator, you do rewrite with a negative. You always rewrite something in the denominator with a negative unless the degree of the denominator is literally 1, or in fact, 1 greater than the degree of the numerator. In which case, okay, so that's the integral. This is a linear inside, so the derivative is -1. So this is me multiplying by the reciprocal of -1. Okay. Oh, I rewrote the left side. I actually already did out the right side. Normally I wait to do out the right side. Okay, so now I have this initial condition. So my x is 1 and my y is 0. There we go. Okay, so I get -1 equals 1/2 minus 4 plus c. So I'm gonna add 4 minus 5. So I get 3 minus 1/2. Yeah, 3 minus 1/2 is 5/2. Let me just triple check that. Yeah, I just want to do it a different way, just to be sure. -3 1/2. So if I add 3 1/2, I get 2 1/2. Okay, great. So that is my e to the, that is my c, okay? So now, why don't you go ahead and put this c back in right here, okay? So back in right here and then solve for y. A little tip, when you solve for y, okay, at some point on your right side, you're gonna have to get common denominators. So see how this is over 2 and this isn't? And actually the c is over 2, so that's convenient. So I would get rid of the negative first, and then you're gonna get common denominators on the right before you start solving for, as part of starting to solve for y, okay? So let's see what that looks like. So this is my first step. So I just put it back in. I'm gonna multiply by a negative on both sides, divide by a negative on both sides, depending on how you think of it. Now I'm gonna do that common denominators on the right. And I rewrote the left, so it looks like this. So now, to get the exponent, to get y out of the denominator, I'm going to take the reciprocal of both sides. Okay. Now, how do I solve for y? I take the ln both sides. So if I rewrite this as a log. So on the left side, you're just going to have y, and on the right, you're going to have ln. This is an alternate way to rewrite it, but I would honestly leave it like this. Alrighty, and there we have it. So, alrighty, here's number 10. Zoom in just a little bit. Okay, so I want you to separate the variables. And then this is going to be, spoiler alert, this is going to have an ln in it. It's not like the last one that has an e. Well, it's going to have an, whatever. When you integrate both sides, you're going to get ln. So you're going to separate the variables, okay? You're going to integrate both sides, and then you're going to start solving for y, okay? And then I want you to find e to the c. So that's the question, what is e to the c? All right, let's go. So when I separate the variables, it looks like this. That's the integral of both sides. The derivative of tangent is secant squared. That's how I memorize this. The derivative of tangent is secant squared, so that means the integral of secant squared is tangent. Okay, I'm going to start solving for y. Oops, I did it kind of differently here. Let me start solving for y. So that would look like y equals e to the tangent x plus c. Okay, so y equals e to the tan x times e to the c. Okay, so now I'm going to sub in y is 5, x is 0, so let's do that. 5 equals e tangent of 0 times e to the c. Tangent of 0 is 0. E to the 0 is 1, so e to the c is 5. Cool. So please put that back in and solve for your final answer, and I'm just going to have you select A, B, C, D, or E. All right, let's go. And the answer is, in fact, C. Okay, C is the answer. So when you put it back in here, you get this. I mean, it's just like you're basically done with the problem, right? So when you put it back in, you're there. There's an alternate way to do it where, you know, whatever. I won't show you the other way, but if you did it a different way and get the same answer, then you are good. Okay, let us do the next one now. Okay. All right, I'm gonna have you do this one now. For this one, there's no intermediate step really that makes sense to ask you. I'm just gonna have you do it all, so it's the 5-step thing, but it's a could be. So when you do this problem, you don't know what e to the c is gonna be because you're not given an initial condition. But if you solve it out, you'll find out that only one of these is in the form that could match, okay? So why don't you select your answer that you got. Okay, let's go over it. So this is the separation of variables. This is the integration of both sides. Okay, I don't have an initial condition, so I'm just leaving the plus or minus. Okay, right? So those are both in the exponent. Okay, so I separate it. So here's the idea, is that you will end up with a coefficient. You're ending up with e to the x cubed over 3 times something. So there's only one of them that's in that form. I mean, the x cubed over 3, so it's b or c, okay? And then it has to be c because c is the one with the coefficient, okay? All right, let's do the last one. Let's do 12 here. Oh, dang it. Hi. Okay, so let's do the last one. We'll do 12 here. So this is similar to the last one where I'm just going to ask you the answer. Now, when you separate the variables, I'm going to give you a tip to keep the k where it is, okay? To keep the k where it is. All right, go ahead. Alrighty, so this is the separation of variables. Now, a lot of people ask, what is the integral of k dt? It is not k squared over 2 because k, even though it's a letter, is a constant, not a variable. So for instance, like for example, the integral of 5 dt would be 5t plus c. So the integral of k dt is kt plus c, okay? So then you do all the rest of the steps. Okay, let's see. Right, turn that into multiplication. So this is the form of my answer, okay? So I have e to the kt. B and c are the only ones with e to the kt. It's not e to the kty, right? And then I need to have a coefficient, not an adding, because my plus c turns into multiplication, right? So it's basically, you know, why c is the distractor. Okay, thank you very much, and yeah, I'll see you on the flip side, and, you know, continue doing the classwork, AB classroom, all that. Thanks, bye.